shall now discuss with one more important concept regarding the roots. At times, frequently, we might be asked in the questions that roots of a particular equation are in the ratio say 2:3, say 3:4. What is the condition? What is the situation that we have to face? Such things may we come across. So, let us now observe that particular case. That is, if the roots of ax square plus bx plus c is equal to 0 are in the ratio m is to n, then there is a beautiful condition. What is that condition? B square by AC is equal to m plus n whole square by mn. One of the most useful formulae we may have to remember. B square by AC is equal to m plus n whole square by mn. If the roots are in the ratio 2:3, then what is B square by AC? 2 plus 3 whole square by 2 into 3, that is 25 by 6. If the roots are in the ratio 3:4, then B square by AC is equal to 3 plus 4 whole square by 3 into 4, that is 49 by 12. Like that we shall be having. Well, what is the reason behind that? What is the proof of this? Is it bulkier proof? No, it's very simple proof. Let us know that so that we may remember it for so many days. Unless you know the proof, you might be getting some doubts about that. So, let us observe the proof of this formula. B square by AC is equal to m plus n whole square by mn. How can it be obtained? Now we shall take interest in learning the proof of that previous condition, that is B square by AC is equal to m plus n whole square by mn. For that, let us assume the roots of that equation ax square plus bx plus c is equal to 0 be in the ratio m is to n. Let the roots be m alpha and n alpha. Instead of taking as alpha and beta, we shall take m alpha and n alpha because they should be in the ratio m is to n. Well, sum of the roots. What is sum of the roots? M alpha plus n alpha. What is that? Minus b by a. What is m alpha plus n alpha? Alpha into m plus n is equal to minus b by a. From here, what do you have? Alpha is equal to minus b by a into m plus n. Okay. Next, product of the roots. What is the product of the roots? M alpha into n alpha is equal to c by a, that is mn into alpha square is c by a, implies mn into what is alpha square? In the place of alpha, can we write minus b by a into m plus n? We can write it minus b by a into m plus n whole square is equal to c by a. From this, mn by m plus n whole square is equal to, here it is c by a, here it is b square by a square. If it goes that side, a square by b square. Isn't it? It is b square by a square. If it goes that side, what happens? A square by b square. A will be cancelled. So that mn by m plus n whole square is equal to, what are we having? AC by b square. Let us just reciprocate that. We are able to observe b square by AC is equal to m plus n whole square by mn. That is why we notice that it is very simple. With the help of 2 or 3 more very simple steps, we are able to catch that b square by AC is equal to m plus n whole square by mn is the suitable condition for that equation ax square plus bx plus c is equal to 0 with the roots in the ratio m is to n. Let us now observe the application of this particular condition with the help of few more examples. Let us now observe the application of the previous concept with the help of few examples. If the roots of ax square plus bx plus c is equal to 0 or in the ratio 3:4, then first option 12b square is equal to 49ac. Second option 7b square is equal to 12ac. Third option 12ac is equal to 49b square. Fourth option none. Very easy and direct way to have the answer. Let us recall the formula regarding them. B square by AC is equal to 3 plus 4 whole square by 3 into 4, that is m plus n whole square by mn. In the case of m, in the place of m we have 3 here, and in the place of n we have 4 here. Therefore, for m plus n whole square by mn, we are supposed to write 3 plus 4 whole square by 3 into 4. By cross multiplying the same, we shall be having 12 into b square. 12b square is equal to 7 square is 49, so it is 49ac. So what is the option which is suitable here? The very first option, 12b square is equal to 49ac. Good. One more example to observe the application. Let us observe one more simple question. So 12b square is equal to 49ac is the only suitable correct answer here. Observe the question. What has been given here? The roots of the equation x square minus 15x plus k is equal to 0 are in the ratio 7:8, then k is equal to. First option 56, second option 46, third option 13. Here you can face this question in two ways. One is by directly using the concept d square by ac is equal to m plus n whole square by mn. And the other is, see, 7:8 he has given. 7 plus 8 is 15. We are able to observe here. If at all 7 and 8 are the roots, actually product of the roots is 56. So it is 56 by 1. 56 is correct here. Therefore, you can tick this one. So believing that the roots are 7 and 8 and in the middle sum of the roots is 15 is being balanced there, you can have the product of the roots as 56. So k by 1 is 56, that is k is equal to 56. Or otherwise by using the technique b square by ac is equal to 7 plus 8 whole square by 7 into 8. What is b square? 225. What is AC? K. It is 7 plus 8 is 15. 15 square is 225. 7 8s are 56. By cancelling 225 on both the sides, we will directly be having k is equal to 56. That is another way. Of course, by not using this condition also, we are able to trace the answer as 56, provided you must observe. Observation is very important here. Sum of the roots is coincided with 15 here. So 7 and 8 are the roots here. Therefore, product of the roots must be 56. Product of the roots must be 56. Yes. Regarding these common roots, we shall observe and enjoy one more question regarding the concept. Look at this. If 1 plus I is a common root of a1x square plus b1x plus c1 is equal to 0 and a2x square plus b2x plus c2 is equal to 0, then the first thing, a1 b2 minus a2 b1 is equal to a1 b1 plus a2 b2. Second option, b1 c2 minus b2 c1 is equal to b1 b2 plus c1 c2. Third option, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Fourth option, none. We are not knowing the values of a1, b1, c1 and a2, b2, c2 at all. He is saying that 1 plus I is a common root. What does it mean? Are you thinking to substitute 1 plus I in the place of x in both the equations? It is a tedious job. Here, we are supposed to use a very simple logic. 1 plus I is a complex number. For any type of quadratic equation, if 1 plus I is a common root, automatically the other root is 1 minus I. The thing here to be observed is 1 plus I is a root of this equation, 1 plus I is a root of this equation also. So, the roots of this equation are 1 plus I and 1 minus I. Similarly, roots of this equation are also 1 plus I and 1 minus I. As a result, what can we get? Both the roots are common. Both the roots are common. Therefore, these two equations give similar roots. So, in such a case, what must we possess? a1 by a2 is equal to b1 by b2 is equal to c1 by c2. That must be had. It's a beautiful observation. We could have arrived at this conclusion justly because 1 plus I is a common root. What is the type of the number 1 plus I? It is a complex number. So, one complex number is a root means its complex conjugate is also a root. So, 1 plus I and 1 minus I are also the roots of both the two equations. That is, the two roots are common for that. Therefore, we must have a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Yes, if you multiply one particular equation with a suitable constant, you will be able to get the second equation also. In such a case only, we shall be having both the roots common. Yes, what a beautiful observation it is. Just like this, this question can slightly be changed here. You observe this question. If 2 plus root 3 is a common root, what is the answer? Previously, it was a complex root. Now it is an irrational root. What should be our opinion? Look here, 2 plus root 3 is an irrational number. In the beginning itself, we could have observed and noticed that for a quadratic equation, irrational roots occur as conjugate surds. Thereby, if 2 plus root 3 is a root, automatically 2 minus root 3 should also be a root. Therefore, 2 plus root 3 is a root of this equation means 2 minus root 3 is also a root. Just like that, 2 plus root 3 is a root of second equation means 2 minus root 3 is also a root of that equation. Here also, we are having both the roots common. Both 2 plus root 3 and 2 minus root 3 are the roots of the equation. It does mean, again the same answer. Again the same answer we must have. That is, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. By observing the previous problem and the changed problem, we can state a particular statement if either an irrational root or a complex root becomes a common root for two equations, then both the roots will be common. Both the roots must be common roots. That is, in those two equations, ratios of the coefficients must coincide. That is, a1 by a2 is equal to b1 by b2 is equal to c1 by c2. It's a useful and beautiful observation. Well, one more thing we shall see. If 2 plus root 3 is a root of x square plus bx plus c is equal to 0, then b plus c is equal to, this is the question. We are supposed to have the values of both b and c, thereby you will be getting b plus c, and it is not difficult at all. 2 plus 3 is a root. Let me write alpha is equal to 2 plus root 3. Clearly and definitely, surely, beta is equal to 2 minus root 3 must be the other root, isn't it? Well, by alpha plus beta, what are you having alpha plus beta? It is 4. Sum of the roots is, what is alpha beta? Alpha beta is the product of the roots. 2 plus root 3 into 2 minus root 3. That is a plus b into a minus b. It gives you 4 minus 3. That is 1. Let us now encash these two. Alpha plus beta is 4. So, sum of the roots is 4. But what is the sum of the roots here? Alpha plus beta is equal to 4 implies minus b by 1 is equal to 4. That is, b is equal to minus 4. Happy. Again, alpha beta is 1. What can you achieve from this? What is alpha beta? Product of the roots. What is the product of the roots here? C by a, that is c by 1 is equal to 1. Therefore, c is equal to 1. We are happy? We are able to get both b and c. b is minus 4, c is 1. Hence, what is b plus c? Minus 4 plus 1, that is minus 3. So, to answer this question, what piece of knowledge is being used here? 2 plus root 3 is a root implies 2 minus root 3 must also be the root. Thereby, adding them we get 4, multiplying we get 1, that is sum of the roots and product of the roots concept gives us b is equal to minus 4 and c is equal to 1, thereby b plus c is equal to minus 3. Here we are very much interested in dealing with the nature of the expression ax square plus bx plus c. It can be observed and studied in different corners. Let us simplify this in another way. This is a into x square plus bx by a plus c by a. This is equal to a into x square plus b by a into x. Let us now try to view this as a perfect square. Here the coefficient of x is b by a, half of it is b by 2a, square of it is b square by 4a square. Let me now by 4a square and subtract the same. Definitely it makes no difference at all. This is equal to a into, observing these three, you can have this as x plus b by 2a whole square plus, if you take this as the LCM, 4a square, 4ac minus b square. Again, this is a into x plus b by 2 plus 4a square by 4a. I have multiplied it with this. So, with a suitable simplification, rather transformation, if you write this y is equal to etc., 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 then it can be converted to the form x square is equal to 4ay, one of the standard forms of a parabola whose axis is either y-axis or parallel to y-axis. So, from this discussion, we believe in one thing. If you want to represent the graph of a quadratic expression x square plus bx plus c, definitely it takes the form of a parabola. Even that parabola will have its axis either parallel to y-axis or y-axis itself. So, it takes either this form or, and the openness of this parabola, will it be upwards or downwards? It will be represented according to the sign that can be given to A. If A is positive, the parabola will be opened upwards, and if A is negative, it will be opened downwards. Let us observe all those things in a detailed manner. It is an easy matter to write x square plus bx plus c as a into x plus b by 2a whole square plus 4a minus b square by 4a. Here, two cases will arise. Case 1. A is greater than 0. Then, a into x plus b by 2a whole square is also greater than or equal to 0. Why? Because x plus b by 2a whole square is square, it is greater than or equal to 0. Of course, it may become 0 when x is equal to minus b by 2a. Therefore, if you add the quantity a into x plus b by 2a whole square plus 4ac minus b square by 4a on both the sides, we shall be able to observe this entire expression is greater than or equal to 4ac minus b square by 4a. This is of course nothing but ax square plus bx plus c is greater than or equal to 4ac minus b square by 4a. In this particular case, that is when a is positive, the value of the expression ax square plus bx plus c is always greater than or equal to 4ac minus b square by 4a. It does mean that this particular number is nothing but the minimum value of the expression ax square plus bx plus c. This is always greater than or equal to. Well, let us see. When can this expression is exactly equal to 4ac minus b square by 4a? In only one case. That is when x is equal to minus b by 2a. From this simple step, we are able to conclude two things. Number one, when a is greater than 0, the expression ax square plus bx plus c will have the minimum value, that is 4ac minus b square by 4a. Secondly, that minimum value will be attained at x is equal to minus b by 2a. This is a beautiful observation. This is the result of case 1, that is when a is greater than 0. It is now the time for us to deal with the case a less than 0. What happens when a is less than 0? A is less than 0, that is the other case that we have to discuss with. If a is less than 0, then a into x plus b by 2a whole square is less than or equal to 0. Why? Because x plus b by 2a whole square is non-negative. We are multiplying this with a non-negative number, so inequality will not change, less than or equal to 0. And adding a into x plus b by 2a whole square plus 4ac minus b square by 4a on both the sides, we shall be having this expression is less than or equal to 4a. This is of course nothing but equal to ax square plus bx plus c is less than or equal to 4ac minus b square by 4a. As in the previous case, we will be able to conclude two things once again. The first thing, this expression is always less than or equal to this. That is, this can never exceed 4ac minus b square by 4a. That is, the maximum value of the expression ax square plus bx plus c is 4ac minus b square by 4a. Okay, when a is less than 0 only. Moreover, this so-called maximum value is equal to this expression, that is, this attains this maximum value only when x plus b by 2a is 0, that is x is equal to minus b by 2a. Yes, by studying the expression ax square plus bx plus c, of course by writing it as a into x plus b by 2a whole square plus 4ac minus b square by 4a, we are able to decide the boundaries of the expression, that is, when can it attain the maximum, when can it attain the minimum, what is the so-called maximum value or minimum value. We are able to notice. Let us have now a conclusion. If a less than 0, this expression has the maximum value. If a greater than 0, this expression has the minimum value, and both the values are of course 4ac minus b square by 4a, and the maximum or the minimum will be attained only at x is equal to minus b by 2a. The only thing that you have to recollect is it is the maximum value when a is less than 0 and it is the minimum value when a is greater than 0. Well, let us express the same in terms of, in view of a graph. Observe this graph. This is of course the graph of the expression y is equal to x bx plus c, y is equal to x square plus bx plus c. You see, the curve comes down, attain a particular position, and again it goes up. Therefore, simply by noting down the nature of the graph itself, we can conclude that this has a minimum value. Where does that so-called minimum value exist? Minus b by 2a and 0. The so-called minimum value is 4ac minus by 4a. As we could discuss and observe just now, this is the graph in which we are able to demonstrate the nature of the graph to contain the minimum value, of course, as a is greater than 0, and its minimum value is attained at minus b by 2a comma 0, and the minimum value is 4ac minus b square by 4a. Now, we observe the graph when a is less than 0. This is of course the graph of the expression y is equal to ax square plus bx plus c, the quadratic function. As a is less than 0, this is opened downwards. As before, here also we can make so many conclusions. Observe the graph. It goes up, etc., and it reaches certain position, and again it comes down. Thereby, we will be observing that it has a maximum value at a particular instant. What is that maximum value and where does it occur? What is the point corresponding to that on x-axis? It is again minus b by 2a comma 0. And this maximum height or the maximum value is again 4ac minus b square by 4a. Like this, we are able to express both the maximum value and minimum value according to the particular case when a less than 0 and a greater than 0 can be observed in a graph like this, so that either maximum or minimum can be attained at minus b by 2a and 0, that is x is equal to minus b by 2a, and maximum value or the minimum value is given as 4ac minus b square by 4a. Well, let us observe the nature of the expression corresponding to different roots in the next discussion. Observe this graph. This is again a parabola opened upwards. Therefore, a is greater than 0. This is the graph of y is equal to ax square plus bx plus c. We can see in the graph itself the parabola cuts x-axis at how many points? 2 points. Let these points be represented as alpha and beta. Therefore, this is the point alpha 0 and this is the point beta 0 on x-axis. Actually, on x-axis y is equal to 0. What is y? Ax square plus bx plus c. So, ax square plus bx plus c is equal to 0 has 2 answers, means 2 roots. Therefore, the equation ax square plus bx plus c is equal to 0 has 2 distinct real roots. When can it happen? Discriminant is greater than 0. Discriminant is greater than 0. Okay. Now, it is the special interest is the case in the present diagram. That is, when can this expression be positive and when can this expression be negative? It is very important and useful to discuss with that concept. Look here. Between alpha and beta, we are sure that the graph of the expression, rather the diagram, lies below x-axis. Below x-axis means, below x-axis we all know that y coordinates are negative. Either in the 4th quadrant or in the 3rd quadrant, y is negative. Y is nothing but that expression. Therefore, the expression is negative. If you take x here, if you substitute here, where can the diagram is available? Below x-axis. As it is below x-axis, then this, if you write this is y is equal to f of x, then if you take x here, f of x is negative. If you take x here, f of x is, to have f of x, you may go around above x-axis. If you take x here, what is f of x? If you want to discuss, to meet with f of x, you have to come down. Suppose you take x here. Then what is f of x? To deal with f of x, you have to move upward x-axis. Here is a positive region, but this is negative region. So, viewing all these concepts, what are all the things that you can declare? Number 1, alpha less than x less than beta implies, for this x, are you able to have the diagram below x-axis or above x-axis? Below x-axis. And below x-axis, the y coordinate is negative. That is, the expression is negative. Therefore, ax square plus bx plus c is negative. Well, the second observation, if you take x here or there, in either case, we are observing the graph above x-axis only. Therefore, for this x, f of x is positive. For this x, also f of x is positive. What is f of x? X square plus bx plus c. Therefore, either x less than alpha or x greater than beta. In either case, we see that x square plus bx plus c is greater than 0. Well, this is the diagram for a greater than 0. Here, x lies between the roots. Expression is negative. Let us frame a sentence corresponding to this case. If x lies between the roots, expression and a have opposite signs. Expression is negative, a is positive. In the second case, if x does not lie between the roots, what does it mean? Either x is less than alpha or x is greater than beta. In these two cases, the expression is positive, a is also positive. Therefore, expression and a have same sign when x does not lie between alpha and beta. This is the diagram corresponding to the case when discriminant is positive, that is, it has two real roots. For those two real roots, if x lies between the roots, then expression and a have the opposite sign. If that x does not lie between the roots, that is, either it lies beyond alpha, behind alpha, or beyond beta, in that case expression and a are of the same sign. Same sign, okay. What is the sign? Positive sign or negative sign? Observe the graph. You can easily mention the sign. Well, let us now observe another diagram corresponding to the case when a is less than 0. Let us investigate the nature of the graph. X of y is equal to x square plus bx plus c when a is less than 0. As a is less than 0, the graph is a parabola opened downwards. Moreover, as it cuts x-axis at two distinct points, we see that the equation ax square plus bx plus c is equal to 0 has two different real roots. Hence, the discriminant d is of course greater than 0. Let us name this as usual alpha, this is beta. This point is of course alpha 0, this point is of course beta 0. Well, again two cases will arise. Number 1, alpha less than x less than beta. What can you say in this case? You have taken x here. To know about f of x, should you move upwards or downwards? Upwards. So the diagram, that is the graph, that is the expression value of y lies available in the first quadrant, or that is above x-axis. Above x-axis, surely this expression is positive. Why? Because y coordinate is positive above x-axis. Therefore, this is positive. So, alpha less than x less than beta implies ax square plus bx plus c is definitely positive. Good. Secondly, if the x taken by us lies either behind alpha or beyond beta, then to know f of x, should you move downwards or upwards? Downwards. So the graph is available below x-axis, and below x-axis the region is negative region in terms of y. Therefore, either x less than alpha or x greater than beta, in both these cases we are able to have the graph below x-axis. What does it mean? We are able to have the graph below x-axis, that is in the negative region. Therefore, ax square plus bx plus c is negative. Therefore, x less than alpha or x greater than beta, in both these two cases ax square plus bx plus c is less than 0. Again, let us make a comment. If a is less than 0, expression is greater than 0 in the first case. So, in the first case, expression and a are of opposite sign. What is the first case? when x lies between alpha and beta, the expression and a are of opposite signs. Similarly, in the second case, that is when x lies either behind alpha or beyond beta. That is, if x does not lie between the roots alpha and beta, in that case, expression is negative, a is also negative. Therefore, a and expression are of same sign. Are of same sign. This is the study of this diagram relative to the roots. Let us now a common comment with in view of a single expression. Look here. We have already known that ax square plus bx plus c is equal to a into x minus alpha into x minus beta. Thereby we will be able to have x square plus bx plus c by a is equal to x minus alpha into x minus beta. Good. First case, if x lies here, what do you say? X alpha less than x less than beta. So x minus alpha is positive and x minus beta is negative. Product is negative. Fraction is negative. A fraction is negative means numerator and denominator are of opposite sign. So it is happening either in this case or in the previous case, that is when a greater than 0 also. Well, the next one, if x lies here, x is less than alpha, so x minus alpha is negative. X is less than beta, so x minus beta is also negative. Negative into negative, positive. So this expression is positive. As and when you say that an expression is positive, you say that both numerator and denominator of same sign, that is x square plus bx plus c and a are of same sign. Same thing is happening here also. Yes. This is the discussion when d is greater than 0, that is when the quadratic equation ax square plus bx plus c is equal to 0 has two real roots. Well,